So let's evaluate some trig functions, and the way we're going to do that is with the help of the reference angle. So if we want to try to find the sine of 135 degrees, for example, how would we do that? Well, we can do that through the use of reference angles with a two-step process. First of all, we want to find its reference angle. So what's the reference angle of 135 degrees? Remember, that's this remaining part over there. Well, if the entire sweep was 180 degrees, and the first sweep was 135 degrees, we're left with a 45 degrees. So we would say then that the sine of 135 degrees is the same thing as the sine of 45 degrees. That's our reference angle. The second part that we need to determine is something about its quadrant. Well, we notice that the sweep will be, or the initial angle 135 is in the second quadrant. Now, why is that important? Because that helps us determine the sine. Now, in the second quadrant, we know that the sine is positive. So what that's helpful for then is that I'm going to make sure that I have a positive sine with 45 degrees. And you'll see why exactly here in a few minutes. So do you remember what the sine of 45 degrees were? That was one of our special triangles. 30, 45, and 60 degree angles are going to pop up all the time. And so we remember what the sine of 45 degrees were. That equaled root 2 over 2. And because we know that the sine of 135 degrees is in the second quadrant, and sines are positive in the second quadrant, I know then that my value is root 2 over 2. There's no negative in that particular, there's no negative here. The value is root 2 over 2. So we can find angle measurements of degrees greater than 90 degrees by using the reference angles to help us determine what some of those trigonometric functions are. Cosine of 4/3 pi. How can we evaluate that? Well, first of all, we have a two-step process which begins with, can we identify its reference angle? Reference angle was the remaining angle closest to the sweep to the x-axis. So if 4/3 pi goes all the way past pi and a little bit more, my reference angle then is this little value right here. So what is that value? Well, I know it's pi, or a sweep of pi all the way to the x-axis. This remaining bit is another third pi. So cosine of 4/3 pi also equals the cosine of 1/3 pi, or pi over 3. Now, do you remember what the value of cosine pi thirds are? I was getting back on some of our special triangles. So cosine of pi thirds equals 1/2. So are we done? Well, if you remember that, you're almost all the way there. If you did not remember that, then this is something where you need to go back and start practicing and remembering what some of those key values were. So the cosine of pi thirds is 1/2. The second thing is we need to determine which quadrant cosine of 4/3 pi is in, so we know if we have the right sign or not. Okay, notice that I'm in the third quadrant. What do we know about what are the positive trig functions in the third quadrant? Well, what we remember is that only the tangent and the cotangent, a smart trig class, trig tells us that tangent and its reciprocal cotangent were only positive in the third quadrant. So anything else would be negative. Therefore, therefore cosine of pi thirds, which equals 1/2, that's going to have a negative value. So what is the cosine of 4/3 pi? Is negative 1/2. And lastly, the cotangent of negative pi thirds. I have negative pi thirds already defined, so I see what my angle looks like. Two-step process. The first step is determine what its reference angle is. So if it's a negative pi thirds, it looks like it's going to be a positive pi thirds as my reference angle going backwards, or going back to the x-axis. So the cotangent of negative pi thirds is equal to this reference angle, which is a cotangent of pi thirds. However, we need to determine the sine. what is the sign of the cotangent function in the fourth quadrant? In the fourth quadrant, cotangent is only positive in the first and third quadrants. So in the fourth quadrant, the cotangent angle would be negative. So I need to insert a negative value inside of that, or prior to that cotangent function, because I know that my cotangent function is negative in the fourth quadrant. Now, what was pi thirds, or the cotangent of pi thirds? If we remember our special triangles again, that would equal root 3 over 3, and then with a negative number in there. Now, I hope you're all right understanding that to find and evaluate trig functions by using reference angle, there's only two things we really need to do. One, determine what its reference angle is. Then two, find its quadrant and use those two things to help us determine the sign. The other part that we might have to go back and remember or get practice again is just to remember what some of those key values were for our 35 or 30, 45, 65. Let me start over again. Our 30, 45, and 60 degree angles, and some of our key radians as well, pi thirds, pi fourths, pi sixths, and whatnot. If you can go back and remember those values, because those values will pop up a lot, you can go ahead, because you committed to memory or you're familiar with them, you knew fairly quickly that the cotangent of pi thirds is root 3 over 3. That's what we learned before. What we learn now is just simply the idea of what a reference angle is and how can we determine by the use of its quadrant what the sign of that particular reference angle would be as well, or the sign of the initial angle based on which quadrant it's in. Now I wanted to do two more examples for you here. That's going to add just one element prior before we get into our two-step process. Tangent of 14 pi thirds. First of all, we realize that we need to kind of determine its coterminal angle first, because this is too many revolutions around the circle. We want to get it in its first revolution. So how many multiples of pi do we need to subtract from this to get a coterminal angle? Some people like to write this as a mixed number, which becomes 4 and 2/3. That 4 then becomes an indicator that we are 4 revolutions of pi too heavy on this problem. So let's take 14 pi thirds and subtract 4 pi from it. Common denominators. And then it looks like I'm left with 2/3 pi. So a coterminal angle of 14 pi thirds is 2/3 pi. That's helpful. That was helpful for me at least, maybe not for you, but it's helpful for me because then I can draw a picture. And again, for me, pictures are useful. I'm able to go ahead and determine that 2/3 pi is roughly in that direction. But more importantly, I now know what quadrant it is in. That's kind of what the bonus point was. So we have a coterminal angle of 2/3 pi. Okay, that was all the work we needed to do before we get into our process, was to find the coterminal angle. Now we can go to our two-step process, which is asking us to find its reference angle. So the reference angle then is this amount right over here, and that, if 2/3 2 pi, that gives me 1/3 pi left over. So let's see if we can go ahead and kind of shape up what's going on here. We started with a tangent of 14 pi thirds. That is equal to, because we know coterminal angles are equal to the regular angle, that's equal to the tangent of 2/3 pi. I'm losing room right there. Yeah, I want to write this all out, so let me just write that all out a little bit deeper here. So tangent of 14 pi thirds is equal to the tangent of 2/3 pi, which equals, remember, reference angles equal their beginning angle or their incident angle, and so the reference angle was a tangent of 1/3 pi. So step one, well, step pre-1 and 1, now we want to find what quadrant it is in so we can determine its usefulness as far as it's positive or negative. Quadrant 2, Well, I know that in quadrant 1 or 3, tangents are positive, and that's the only place they're positive. So therefore, the tangent in the second quadrant and fourth must be negative. All right, so we are now left with a negative tangent of 1/3 pi. And remember what 1/3 pi or pi thirds? I guess I could write it also like this because it's meaning the same thing. The tangent of pi thirds is √3, and then I have a negative in front of that being. So the tangent, evaluating the tangent of 14 pi thirds, first find its coterminal angle, then use its reference angle and the quadrant it's in to determine the value and the sign of our result. So let's begin with the secant of negative 17/4 pi. Before we begin our two-step process, we really need to figure out what its coterminal angle is. So we have some revolutions of 2 pi we need to add to this to get to the coterminal angle. Negative 17/4 is the same thing as negative 4 1/4. So I know that I need to put on 3 multiples of 2 pi in order for this to become a positive value right there. So to do that then, let's take negative 17 pi fourths and add to that 3 multiples of 2 pi, which will be a 6 pi. Reason why we chose that number, let's do our math here and find out what happens. I'm just going to go straight across for a second. So negative 17/4 pi plus 24/4 pi equals, what is that, 7/4 pi. All right, so I found my coterminal angle of 7/4 pi. So let's figure out where that's at, because I like to draw pictures anytime that we can. 7/4 pi is almost 8/4 pi. It's right there. Is the angle, and the angle as we measure it from the standard position all the way around. So there's my theta, or my initial theta, of 7/4 pi. All right, that was all my pre-work to get to this particular point. Now I go to my two-step process. I don't know why they call it a two-step process. It should be a three-step process because this was a step. All right, step 1 is figure out what its reference angle is. So its reference angle is this remaining amount to the nearest x-axis. And so if that goes over 7/4 pi to get all the way to the beginning, it's really 2 pi, take away 7/4 pi, and that will equal 1/4 pi. So my theta prime equals 1/4 pi or pi fourths. All right, we can use that now to think about what we have accomplished so far. So let's go ahead and kind of see the overview here. We started with the secant of negative 17/4 pi. That equals its coterminal angle, which was the secant of 7/4 pi, positive 7/4 pi, which equals its coterm, or its reference angle, which is the secant of pi fourths. All right, so notice what we've done as the overview. Started with our initial angle, converted it to our coterminal angle. From there, used our coterminal angle to determine what its reference angle is. And now step 2 will help us determine if we have the correct sign of this angle. So it's in quadrant, this line is in quadrant 4. What do we know about secants in quadrant 4? A smart trig class. So in this one told me cosine and its reciprocal were positive. The reciprocal of cosine is secant. So this is a positive value, and I just might put a positive there just as a reminder of that. And so what is the value of the secant of pi fourths? Again, if we remember our figures, our stuff, That's the reciprocal of the cosine of pi fourths, which is the root 2, and it's a positive root 2 because it's in that quadrant where secants and cosines are positive. So there's a little bit of how we can evaluate trig functions using reference angles.